What's up? Welcome to Backend Stuff. This is episode 3 in Elixir Basics. We're going to learn about numbers and basic arithmetic we can use with them. It's time to get our hands dirty and write some code today. We will be creating modules, writing some basic math functions, and learning how to use the pipe operator to transform values. So with that being said, let's go ahead and open up our terminal. Command space terminal. All right. I'm just going to make this a little bigger so you can see it, and CD to the desktop. And from episode 2, you'll remember how to create a new project, and that is mix new, and then the name of the project. We're just going to call it numbers. And there we go. It created our skeleton project, and go ahead and CD into that directory, CD numbers, enter. All right. Cool. And now let's open up Visual Studio Code. Let's see, open folder, the numbers folder. Okay, close the get started, and let's expand the lib. And let's go ahead and just delete this numbers module. Command delete, move to trash, and right click lib and say new file. And let's call our new file basic_math.ex, enter. And we have to create a module. And to create a function, they have to be within a defined module, or they won't be able to compile and you won't know how to access that function. So def module, enter. And as you can see, it takes the name of our file and camel cases it. So that is our module name. And then to create a function, you just need def, so definition, and a name of a function. And since we're dealing with numbers today, we're going to be making basic math operators. And so let's call this one add. And that is going to take, let's do open parentheses. It's going to take an addend _1. And the second argument is going to be an addend _2, close parentheses, and then open up the function with a do, and then hit enter, and it will automatically close it with an end. Okay. With floats and integers, I guess we should talk about those first. So integers are just whole numbers, one or more digits, but no decimal point. And floats are 64-bit double precision numbers. That means they have at least one decimal place. 3.4 would be a float value. And the simplest way to put this right now, so you can understand it, it just means that the 64-bit double precision, it can have up to 15 to 16 decimal places, and that's a float value. And an integer has no decimal places. But there are some things you can do out of the box with just basic operators in math with integers and floats. And the first one is add. And the cool thing is with functions, the last expression is implicitly returned. So you don't have to return a value. We can just do this. We can do addend _1 space plus addend _2. And we don't have to return the value, just it sitting here knows that that is the value we return, which is pretty neat. So if we go to our terminal, and if you remember how to open the Elixir shell, it's IEX space -S space mix, and that just compile our project. And now we have access to our basic math module. So basicmath.add. And we can just pass in two numbers. So open parentheses, let's go 2, comma, space 5, close parentheses, enter. So 2 plus 5 equals 7, which is which is pretty neat. And now if you remember, we can do exports basic math, and we see that we have one function available with a /2. That /2 is called an arity. And it's often used when you see definitions of functions. And what an arity refers to, it's the number of arguments that function accepts. So we know that our add function, it accepts 2 arguments. And that would be the addend 1 and addend 2. All right, so that's what that means. And if we were to say, if we wanted to see the definition or our documentation to the add function, you can do h space BasicMath.add and then hit enter. And we don't have detailed documentation written out for this function yet, but we do see the arguments it takes. It's addend 1 and addend 2. And in the documentation, you would describe what those parameters are, what kind of values they are. In this case, they're just numbers. They accept integers or floats. So that's pretty neat. And just to show you that they take integers or floats, we can do basic math add. We can put a 3 here and a 4.5 here, close parentheses, enter, and we get 7.5. So that works with integers and floats. All right, and one last thing, when functions are super easy and short, like we just have addend 1 plus addend 2 here, we can do what's called the shorthand version of our function. And the way we do that is, let's just delete this all the way up to the do. So right after the arguments, closed parentheses, put a comma, space do, colon, and then you do what was just in the function, which is addend 1 plus addend 2, and then save it. That's all we need. That is a shorthand function. So you don't need an end anymore when it's all in one line. So if we go back to our terminal and we hit recompile, we can now do the BasicMath.add, the 3 plus 4.5, which is 7.5, and it works the same exact way. So that's pretty neat. All right, let's just write a couple more functions. We need a subtraction function, we need a multiplier, and we need a divide. So let's just do that. So subtract and then open parentheses, and we have the menu end, comma, and the subtrahend, close parentheses, do. And then that's as easy as taking the menu end minus the subtrahend, and that function is done. Now we could write it in the shorthand version as well. I just want to write functions both ways so you get used to the most common way you're going to be writing functions. And then let's go ahead and do a multiply. So def multiply, and we're going to pass in our multiplier and our multiplicand. Okay, there we go. And we're going to go ahead and just multiply those together with an asterisk. And that is our multiplier, asterisk, multiplicand. And that's all we have to do. So all these basic operations are built into Elixir. The add, minus, multiply, and now we're going to do divide. And that we send in the dividend and the divisor, do, and then that is the dividend space / space divisor. And that is how you divide. All right, and if we want to try out some of this code, let's go ahead and open up our terminal again, and let's recompile. And now if we do BasicMath.divide, open parentheses, we can do like 7, 3. So that's 7 divided by 3, close parentheses, enter, and we get 2.333333. All right. Now that's not very visually pleasing. So let's say we wanted to round that to the nearest hundredth place. Let's go ahead and do a new function called def round underscore up. We're going to round it up and just pass in the value and then start the do and end. And we have, so float has built-in functions and we're going to round to the ceiling. So float.ceil. And as you can see, it takes 2 arguments, and that is a float and then the precision range. And the float is our value, and the precision range, we're going to use 2. That means 2 decimal places, so the 100th spot. And if we wanted 4, we would put a 4 there, 6. You get it. And so float and integer, they have a lot of built-in functions, built-in macros that we already have access to. And a way to see that is, let's go ahead and pull up our terminal. We can do exports float, and you can see all the functions here. You can see ceiling with 1 argument to be passed in. You can see ceiling with 2 arguments. And if you want to know the difference, you can just do h ceil. So ceiling with 1 argument returns the smallest integer greater than or equal to the number. All right. And then if you want to designate how many decimal places you always want back, you would use the function that we just used where we passed a 2 in. We always want the 100th value. All right. So that's our roundup value, right? Let's go ahead now and make a new module where we can grab functions from a different module and use them somewhere else. Okay, so let's go ahead and make a new module. Right click lib and say new file. And let's call this one calculator. Calculator.ex. And then we need to define the module. So def module and calculator. All right. And now if we want to, let's see, we need to let's create a function that will find the percentage of a value. So def find percentage of value. And the arguments we're going to pass in is the percentage and the value we want the percentage from. All right. So those are the 2 arguments. And then go ahead and type in do. And then it will close off with an end there. And so this is basic math, right? We know that a percentage times a value will return a value, right? So let's go ahead and just do value times open parentheses, our percentage divided by 100, close parentheses. So that will take our value times the decimal version of our percentage. Let's go back to our terminal. Let's recompile. And now if we call calculator dot find, we can say 25% comma of 100. Nice easy number. We know it's going to be 25. So there we go, 25.0. It returns a float to us. Okay. But we already wrote all these functions, right? So let's go ahead and comment this out and use our functions for this now. So we need to find the decimal value of our percentage. So decimal percent equals, so we're creating a variable called des_percent, and we need to call our basic math module. So basic math dot divide. And now we basically have to pass in 2 arguments, right? Our percentage and 100 because we want to divide it by 100. So we're doing this part right here, our percentage divided by 100. And then we can go ahead and do basic math dot multiply. And we're going to pass in our decimal percent, which is the value we just saved here. and then comma, our value. Close parentheses. Whoop, too many close parentheses. Save it. And let's go back into our terminal. Recompile this. And now if we call our calculator.findPercent and pass in the same values, we should get 25.0 again, right? Enter. And there we go, 25.0. And we're using functions we already wrote, which is pretty cool. But it gets cooler. So Elixir has pipe operators, which allows us to basically string a bunch of functions together and transform the value automatically without creating extra variables we have to then pass into different functions. So let's go ahead, comment this out. And with a pipe operator, we're going to transform our percentage value because we have orders of operations going on here. And we need the percentage divided by 100 first, then multiplied by the value we want the 25% of. So we're going to just take the value percentage right there, hit return. And then if you do a pipe and greater than symbol, that is the pipe operator. And then we do basic math dot divide here. And so when we transform a value through the pipe operator, so percentage is already being passed into this function, okay? So all we have to do is add the second argument, which is 100. Close parentheses, too many parentheses, and then hit enter. And now we have percentage divided by 100 right here. So that's 0.25. Do another pipe greater than symbol, and then basic math dot multiply. And so the 0.25 is just getting passed right on through. So we only need the second argument again, which is our value, which is 100, right? So our value 100 here, and then save it. And basically what's happening here is percentage is being transformed. Percentage is being divided by 100. And then that 0.25 is then being multiplied by our value we pass in. So if we saved it, go back to our terminal and we recompile. And now if we call that same thing, calculator.find percentage of value, 25% of 100, hit enter, we get the same exact value. So that's pretty neat. So that's how pipe operators work. They're just chained together and you don't have to create multiple variables just to solve a problem. You can just pass them on and on and on and transform them. And now I've got a little challenge for you guys. I want you to take this. I want you to find the distance traveled when you're given speed and time. So you're going to create a function called find distance traveled given speed and time. Okay. So a little hint here is it's going to be, so speed equals distance divided by time. So using that equation, it's easy. It shouldn't be hard. I want you guys to use the functions we already wrote and pipe operators to return the distance. Okay. Really easy. And also round it to the nearest hundredth. And in fact, why don't we round this value here too? We're going to do basic math dot round up. And since it only takes one value, we don't have to pass anything in because it's taking it from here. So that's pretty cool. So save it. I'm going to just comment this out for now because it'll give us a compile error. Let's go ahead and just recompile our code and try our calculator percent. And this time let's do like, I don't know, 23% of 233. And it rounds to 53.6. Let's do 23,456. So we see it round. See 104.89. It rounded for us. If we went back into our calculator.ex and got rid of round up, it's going to give us a nasty value back. Well, we have to recompile and then do it. And then, so there we go. We have it just drag on and on and on. So our roundup function does work. So given that, I want you guys to do that. And I'm going to post a link to a GitHub repository with a project that will have the solutions. It'll have the solution to this challenge. And if you dig deep enough, you'll be able to find the tests written for all the functions written in this episode. And you'll also see how to properly document functions. And so when you take all that, check it out. I'd really love you guys to try to write your tests for all the functions we just wrote today. And in fact, I'll even show you how to write a test for the add function right now. So if we go into the test directory, the numbers test, let's go ahead. We're going to rename numbers test to basic math test. All right. And let's rename this file. We could have just deleted this, but it's fine. basic_math_test. All right. And then let's change, because we deleted the numbers file, remember? So basic math is, oh, not test. We just want basic math module. And what this does is it runs tests on the documentation. So when you look at the GitHub solutions, you're going to see documentation with examples. And that example code is actually ran when you use this doc test, which is really cool. And so we're going to run a test called add 2 + 3 = 5. That's our test. All right. So down here, just assert, and we're going to do basic math dot add, and then we're going to pass in 2, 3 close parentheses, and that needs to equal. And so when you're comparing, when you're doing pattern matching, it's a double equal sign. So 2 equals, and then 5. Save it. And if we go to our terminal now, Control C twice to get out of the shell. And if we do mix test, it's going to run our tests. And we have 1 test that passed and 0 failures. So that's awesome. Our add function is working how we expected it. So 2 challenges, guys. I want you to write the rest of our tests for both the basic math module, and the calculator module. And then also finish this function, find the distance traveled given speed and time. Super easy, but it's going to let you learn how to access functions and use the pipe operator. And if you guys have any questions, just check out the solutions in the GitHub repository, and also join my Discord channel. We have a back-end stuff Discord channel. The link is in the description. And if you have any questions regarding any of my lessons, hit me up in there. I'm in there all the time. See you guys later.